Good afternoon, good evening, good morning from wherever you are joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Reactor Sydney live stream event. Today I'd like to welcome Michael Ridlin. Hi, Michael.
Hi.
Hi. So Michael is a passionate technologist and Microsoft MVP. Today he will be providing you with top tips for app modernization in Azure. This will be a demo intensive session integrating the likes of Service Fabric, AKS, DevOps and more. This session will be approximately about 60 minutes with about 10 to 15 minutes of those for questions at the end. However, do send us your questions throughout in the Q&A and we'll try and answer as many as possible towards the end. At the conclusion of this session, I'll share with you guys a link to the survey in our Q&A section as well. Your feedback will help us to create our topics to suit our audiences for the future, so please do help us by filling that out. And and if you'd like to reference this session after today as well, we'll be uploading a recording to our YouTube channel in the coming days. But for now, I'd like to give over the floor to Michael to begin the session. Michael, over to you.
All right. Thanks everyone for being here, and today, as we said, we're going to be talking about some top tips for app modernization in Azure and with a few demos as well. So just to give you a background on who I am, I'm co-CEO of a company called XAM, and I've been doing technology for about 20 years, a Microsoft MVP. Just to give you a background on our company, we specialize in Microsoft technologies to do end-to-end solutions. So we mostly sit around that application space, application dev, full stack applications. We work with some great customers over the years. I love our customers, but that's not what we're here to talk about. So we're just here to talk about app modernization today. So let's just talk about why we want to modernize our applications and what sort of value we get from a modernized application. So one of the values that we get is agility. So we get the ability to move faster, so continuous delivery. We get to put things in containers, so we get cost savings there. We also get time to market, innovations that are in the cloud for us, that are hard problems that are already solved for us, like scalability and high availability, and insights and analytics. And also infrastructure costs, and ongoing maintenance. So we're reducing our costs of infrastructure and reducing our costs of the ongoing maintenance. And we've also simplified and standardized our IT. So if we look at the app modernization maturity model, you can see here we've got our existing applications, which are .NET web applications on-premise or with a server in the cloud. So we call those monolithic applications. So we've got a .NET or a different type of application that's running and a relational database that it's connecting. So the next stage, which is the lift and shift, we go cloud infrastructure ready. So this is taking your existing application and just putting it into the cloud on infrastructure as a service, usually VMs, SQL Server running on those VMs. So the next step after we've lifted and shifted, we're looking at going to the platform as a service. So we've got our monolithic applications, but then we're actually using the platform as a service offerings on the cloud providers. So in this case, it could be app service or it could be application insights. And we can also, if we choose to, use containers, Windows containers or Linux containers, depending on how far or what technology you've got. And then after we've optimized our application for the cloud, we can also go and adopt microservices and serverless architectures. So just a little bit of a note around like cloud optimization and cloud native. If you're just running a small couple of servers and you've got a small team and you don't have a big application with large teams that's continuously changing, then moving just to using the PaaS service, say like the Azure App Service, might be a better option than going straight all the way to a microservices architecture. Because really, when you're going to a microservices architecture, then this is for applications that are continually updated. They need to be sort of delivered to millions of users, and it's very complex environments. And you usually have large dev teams working on their own individual areas of the application. So you don't necessarily need to go all the way to the microservices architecture. But what you can do is if you've got a simple application that's running in, say, an app service, then you can actually start adopting some serverless solutions. So you can add a few Azure functions onto your application, or you can easily add use a sort of serverless solution around logic apps where you can add some logic to your applications without having to go into a full microservices application. So when we're going to cloud optimize, then there's minimal code changes. That's the same as if we're going to the cloud optimized and adding a few serverless functions on or some logic apps on. There's still minimal code changes and you're only just changing for the new functionality that you need. If you're going to microservices, then that's needs a new architecture for your applications, and it really needs to be thought out and designed really well. So during our lift and shift, so basically when we're lifting and shifting, we're not changing any code, we're just changing configuration. It's the easiest way to get your applications into the cloud. And it's really easy to put all different types of applications into the cloud as well, because you're just running them on virtual machines. So you can see here that you've just gone onto the infrastructure as a service cloud virtual machines. So the problem with this is the fact that you don't get a lot of that cloud value, like the high availability. You still have to manually do your patching and your upgrades. So the next step after that is a modernized application. So with a modernized application, you don't necessarily need to add new code. There is some minor changes that you need to do to your applications. If you're moving to Docker, then you have an increased density. So when you're moving your applications to the cloud, if you move them into Docker containers, they have this concept of increased density. So this means that you can run more applications on less servers because your Docker containers run a lot leaner than a full virtual machine. The other things that you can get with the cloud obviously is easy integration with DevOps tools and the ability to easily deploy into the cloud. The cons of modernizing the application obviously is containerization is an additional step. So here's an example of an application where we've taken it, an MVC application, which is a .NET application, and we've just made it cloud infrastructure ready and moved it to a SQL Server virtual machine, continue to use all the same tools. Then the next step, cloud optimized, we're using an Azure App Service, monitoring with application insights, and then using CI/CD with Azure DevOps. So I guess to go back to basics, what is a modernized app? So a modernized app is containerized, but I really think it depends on the application if you really want to containerize it, because you don't necessarily need to containerize it to actually have a modernized app, especially if you're using something like Azure App Service, which has a lot of features and functionalities. Like for example, Azure App Service has the ability to run .NET and a lot of other runtimes without having to containerize it. It's got good integration with all the CI and CD services, and you can easily integrate it with any monitoring. Because as soon as you go into a containerized application, then those other things, which is you need to put it into Kubernetes, and that means you'll need to have somebody that knows Kubernetes. You'll need to have somebody that's going to be managing that for you. So sometimes it's a lot easier just to take an application and just use something like App Service and just use the functionality that comes with App Service. So on the flip side of that is if you do have a lot of applications that you want to modernize, then it actually makes it a lot more cost effective to containerize them, because you don't have the extra expense of running a whole operating system. You just have the lightweight Docker instances. So the other thing with the modernized app is it's resilient and it's highly available in the cloud, which when you're using most of the platform as a service, it's really easy to implement. The next step is you've got what they call observability. So your application is monitored You're getting great insights from your application. And the next step after that is DevOps and continuous delivery. So what I might do is just give you a bit of a demo of a modernized application. So taking an application, which is an existing .NET application, and modernizing it. So this application that I've got here is a .NET Framework application. So .NET Framework applications can only run on Windows because the .NET Framework is bound to Windows. If you want to run a .NET application on a Linux machine, then you need to move into .NET Core, and you need to migrate to .NET Core, which I do recommend doing because it is a lot faster than standard .NET, and it's a lot easier to use with containers. But what I'm actually going to show you here is how I've taken this .NET Framework application and I've just modernized it. So here I've got this simple task app application just with a few controllers here. If you look down here, what I've actually created is a Docker file. So this Docker file is basically a file that will allow you to build a Docker image and put it into your Docker registry. So if we look through here, you can see first what I'm actually doing is I'm creating a Docker file, which is it uses the Microsoft container registry, and it uses the standard images that Microsoft provide for you. So you can see here I've got the .NET Framework SDK, and this is for my build. So basically there's two different images that I'm using here as base images. One is the .NET Framework SDK, so I can actually build. And the second one down here is just the Windows Server core to run my ASP.NET application. So initially I set it up to build. From there, I'm actually just restoring the application and copying some files. After that, I actually restore all the NuGet packages. And then after that, I'm actually just running MS build to build the application. After that, I put down the layer, which is basically the Docker image to run my ASP.NET application on, which needs to be the Windows Server core because this is a ASP.NET framework application, so it needs to run on the full version of Windows. And then I'm just putting the files in the correct directory to run the Docker application. So that's my Docker file. So now I want to be able to take my Docker file and I want to be able to build it. And because on this computer I'm not able to actually build this Docker file, what I can actually do is set it up for continuous integration. So in this case, I've gone through and I've set up my GitHub workflows. So you can see here in this directory, I've got a GitHub folder with my workflows, and I've got my YAML file to actually build my GitHub workflow. So you can see here, I'm building and deploying my Windows container, and then deploying it to an Azure App Service. So whenever something's pushed into the master branch, this actually triggers the build, and it's running on the Windows latest. So just to go through some of the steps, first checking out the repository. The next step I'm actually doing is I'm actually setting up application insights. So this application insights will allow me to get that observability in my application. After that, I'm going through, I'm actually logging into my Azure account. So a thing that you'll notice here is I'm using these secrets. So these secrets I'll actually set up in my GitHub repository. So if I just show you over here on my GitHub repository here, if I go to settings, you can see here I've set up all my secrets. So it's really easy to add a secret. You can just come to the secrets here, create a new secret, and that will work. And then you can pick it up in your workflows. So I'm logging into Azure here. After I've logged into Azure, I'm using the Docker logon to log into the Azure Container Registry, which is a container registry that I've set up to deploy my containers to. So after I've set up or connected to the Azure and the container registries, I'm then building and pushing to the container registry. So you can see here, the Docker file that I'm using is the task app Docker file. And then I'm actually tagging it just with the registry name, the image name, and then it's got like a unique value per build on the end of it. And then you can see here I'm pushing this up to my container registry. So after I've built it and pushed it up to my container registry, then I'm deploying the container to the Azure App Service. I'm using the Web Apps Deploy version 2, setting the app name. So basically that app name is the app service name that I'm using, and I'm using that image as well. So I can actually go in here and I can actually show you some of the actions that have run before. So I can actually jump in and I can see one of these actions. We'll see the result of these actions running out. So what I might do is just show you the app service that I'm running. So this is the Azure App Service for containers. So basically this is an app service that can run containers for me. So I've got this set up with basically so I can continuously deploy to this. If we go down here, you can also see that I'm using deployment slots. So deployment slots is an app service feature which will easily allow me to basically create different running instances of the application. So I can easily set up a staging slot, which will allow me to run a different version of the application before I actually put it into production. And then I can come in and easily swap those different slots around. So if I put something into staging and I've changed a few colors, I just wanted to go and check it, I can actually go into the staging version and I can test that before I actually swap it. So I might actually just go through it and show you that as well. So you can see here I can click into the staging slot here, and for that staging slot I have a different URL. So here's my URL for the staging, and then I can go back here and just up here you can see that I can actually just change it. So this is my production application. So one of the things we saw before was like a high availability, and what we can actually do with App Service is we can actually easily scale up and scale out our App Service plan. So you can see here I've come in to my App Service plan. I've got my custom auto scale on. I've gone through and I've actually set up to scale based on a metric. So when my CPU percentage is increased, is over 70, then I increase my the amount of instances that I have by 1. So this is running on Azure App Service. So this is not running in Kubernetes or anything like that. It's just using all the functionality that comes with App Service and just running a container on that as well. And you don't necessarily need to just run a container in Azure App Service. You can also run all different types of applications, like a Node application, a .NET application. So what I might actually do here is just go in and make a change to some content. And I'll just change the color of one of my buttons to red. So I'm just going to commit this and push it up. So I just got some changes on the server to pull down. So now I've just gone in, just made a simple CSS change. And if I come back here and go to my GitHub Actions, you can see that's actually kicked off again. So that'll probably take about 10 minutes to go through and build. And that's actually going to push that all the way through to my app service. We can come back and have a look at it. So just a tip when you're actually thinking about modernizing applications, especially here if you have a lot of applications to modernize, then think about like if you actually need the application and actually do some user research and like analysis to see is this application something that we need? Can it be something that we can replace with a SaaS application? Is it something that we can rebuild really easily in low code, obviously to reduce the maintenance that we have on these custom built applications? So this is where I go back to like user research and actually understanding the users, understanding what they're doing with the applications. But this is all contextual. So if you have a huge amount of applications that you need to modernize, then you need to automate that solution as much as possible, and you need to maybe put them all into the cloud and put them all into a Kubernetes cluster. Have them running, and then slowly actually go through and figure out what you want to do with those applications, if you want to keep them or retire them. So you can do it in different phases and different stages. So another thing to think about when modernizing applications is, can we easily replace it with something like the Power Platform? So a lot of companies are already using Power BI, so that's a strong sort of business reporting tool that a lot of people are already using. We also have on the Power Platform Power Apps. So Power Apps allow us to create custom applications in a low-code environment, but also customize them if we're a professional developer. So there's multiple ways to create Power Apps that can have a good UX, and also a lot of applications that can be easily built just by a data-driven application, just by speccing the data out and then automatically generating the UI for you. And then Power Automate will allow us to easily integrate automation. So for example, just say you have a company that's servicing different parts of a city, say Sydney, and a person calls in sick for one day, then what we're able to do is with Power Automate is pick up that somebody's called in sick, and then from there we can actually go and send out emails to people who would then be able to come in and self-service and say, okay, I can take this person's shift. So this is a good way to actually go in and replace existing systems with a low-code, fast solution that you can easily deploy into your enterprise environment. So Power Virtual Agents as well allows us to easily create chatbots that can be used. With the Power Platform, we've got over 250 data connectors to third-party services. You can also create portals with Azure. So with the portals, you can create ways for you to build a portal that your customer can come to. I mean, there's a good example with Virgin used the Power Platform to create a portal for people booking in massages when they went to sorry, lost my thought. And then we also have AI Builder. So AI Builder easily allows us to add artificial intelligence into our Power Platform applications. And probably the most sort of underrated piece of technology in the Power Platform is the Common Data Service, which is now called the Dataverse. So it has been around for a long time. So we just have a look at what's in the box with the Common Data Service. So the great thing about Common Data Service is it's got all the power of, say, like a SQL database, but it also has a lot of things on top that you would normally have to custom code into your applications. Like, for example, the authentication, authorization, any ordering, any business rules you can actually put down at the database level. So you can actually put them into the database level, and then once you've got them into the database level, there's an API. You can easily connect to it from third-party applications, or you can easily connect to it from the Power Platform applications to actually rapidly build out simple solutions. So this is something that you might consider when going through and looking at your different applications in your organization. So one of the great things about the Power Platform is you can easily build you have a person that's not a real developer come in and build a Power application. They call them citizen developers, but also one of the most powerful things is the fact that there's a very strong pro developer environment. So you can see here, we've got Power Apps that a lot of people can come in and they can actually just build out their own solutions on top of the Power Platform, but we can easily integrate it with Azure services, like API management can be used with the Power Platform, Azure Functions, AKS, and obviously there's a rich DevOps solutions integrated with the whole Power Platform. So this is where you've got the the pro developer code, and then the low code citizen developer working hand in hand to do solutions. So one of the things that that you really need to do is learn to love Docker, because everything containers run everywhere. So if we just actually go through like some of these solutions that run containers for you, so you've got Azure Container Instances, which is basically like a VM, but instead of being a VM, it's just running a container. There's no cluster or anything like that. And then we've got AKS, which is Azure Kubernetes Service. So that's a managed Kubernetes service, which is actually native Kubernetes. So any of the tools that you want to use, like Helm for deployments, all going to work with AKS. The next one we've got along is Service Fabric, and Service Fabric was created by Microsoft to service a lot of, well, build a lot of their own applications, and it was used very heavily by Microsoft teams in different technologies. And this is basically, it's like a cluster that allows you to do high availability distributed solutions. The next one is Web Apps, which is Azure App Service, which allows you to run containers, which is what we just saw in the demo. And then also Azure Batch can run containers for us. So just talking about how we actually use Docker and how we can actually integrate it into our applications. We saw before what we were doing is we were building our own container. And once we had actually built our own image, then we're actually putting it up into the registry. So you can see here, I've got my images, which are then pushed up into my registry. Then we can have our own, in this case, we actually had our own Azure Container Registry where it had our own registries, but there's also public registries that you can use that have public images, which are done by different organizations. For example, what we used in this case was the Microsoft provided images. So I think another tip when you're doing app modernization is to actually, you don't need to overcook it. So if you've got 3 or 5 applications that you need to modernize, do you actually need to go to AKS? There's a lot of great things that come in application service that you don't actually, or that you would have to manually do if you went to AKS. So with AKS, obviously it's a managed cluster, but then actually doing the scalability is something that you need to configure manually. With App Service, a lot of that sort of stuff is done for you. It's very easy to use. It's a little bit more expensive than if you have if you're doing your own or if you manage your own cluster. But if you've got some simple applications that you really just want to put in the cloud and make them modernized, then Azure App Service is actually a really good solution for that. And you can see here that we, I mean, obviously you saw when we set it up with the GitHub Actions, then we easily could connect the CI/CD, but that also happens for all other CI/CD tools. So for example, Azure DevOps has easy integration with Azure App Store as well, Azure App Service as well. So just talking about the differences between AKS, Service Fabric and container instances. So you can actually see here, the Kubernetes service is for production deployments of complex systems. So this is really when you have large team of developers, you have the resources to be able to manage all the ingress and all the complications that come with running Kubernetes. And then from there, if you want to run something simple, then you can either just use Azure Container Instances easily, or web apps that run containers for you. Longer running workloads you can do with Kubernetes, or you can do it with the Azure Batch. And then short running workloads, container instances or Azure Batch. The great thing about Kubernetes is the fact that it's the native Kubernetes, so you can use anything that's available in the open source community as well. So actually one thing that you notice here is our web application, which is an Azure App Service, has the deployment slots feature that we can actually go in and use as well. So just to go in to the differences and why you would use AKS versus Service Fabric. So Service Fabric, like I said, was created by Microsoft. Some of the things that it does really well is run like .NET Framework applications. So if you do have a huge amount of .NET Framework applications and you're not updating them to .NET Core, then Service Fabric could be a good option for you. And another thing that it does is stateful services. So if you're running an application that's live, a live state that needs live state, for example, if you're running a gaming platform that needed that live state and needed that responsiveness, then Service Fabric has some good options and good solutions around that. AKS, on the other hand, is kind of the industry standard for running large clusters and running your container instances. And so, as I said before, the great thing about that is you can use all the native stuff that you've got available. So you can actually see here, if we go in and have a look at this, we're building new. If we're migrating and we want to either cloud optimize it, if we're cloud optimizing it, then if we have a batch workload, then we can use Azure Batch. If we're not doing a microservices architecture, then we're probably going to look at something like App Service, because we don't always need to have a microservices architecture. If we want to have something which is event driven, then we're looking at or short processes, then we're looking at Azure Functions. But these aren't totally exclusive things. So for example, you can have an app service and you can actually extend that application service with Azure Functions or Logic Apps fairly easily. And the next one is if we've got containers and we can easily put something in a container, then we can use container instances. But if we need orchestration, then we need to go down and we need to either use a Service Fabric or AKS. And this is actually the official recommendation from the architecture guides of Azure. If you want the .NET Framework integrated and full support for the Microsoft technology stack, then you're going to be using Service Fabric. Otherwise, you're going to be using AKS. So, so a few notes there is, if you're using .NET Core and the new versions of .NET run on Linux natively, so you can easily create a .NET Core application and run that in Kubernetes, because Kubernetes is really designed around the whole Linux ecosystem. And that's why if you've got a .NET application that's the .NET Framework, then you're probably going to be looking at Service Fabric. So just talking a little bit about messaging and resilience. So a great way to add a message like resilience to your application is to decouple it. So for example, if somebody's coming in and they're trying to book a flight and it's with a third-party website, that third-party website will not want to wait for the response back from the actual airline to see if that person's actually confirm that booking. So what we can actually do is we can actually use queues. We can actually say, okay, we've taken your booking, we're going to add it to a queue, and then from there the queue goes through, and then the consumers or you can have applications that can read from that queue, go and actually confirm the booking for you, and then once the booking has been confirmed, then you can actually send it back through the response queue. So you can easily set this type of decoupled system up using the cloud. So if we have a look at some of the messaging solutions that we have available in Azure, we've got notification hubs for mobile push notifications. Then we also have logic apps, which allow us to, they're actually fairly powerful. We can add full logic to your applications and to your line of business applications. The next one across would be Azure Service Bus and Storage, or Azure Queues. So this is our sort of our main solution for easily decoupling systems and easily sending messages between systems and sending queues. The next one that we look at is Event Hubs, and that's basically for like IoT and telemetry streaming and ingesting that into as a data source. Event grid is basic for event distribution. So an example of this would be the whole of Azure Monitor is like using event grid. So data sources are actually publishing to event grid, which is then going into to Azure Monitor as for the data. And then we've got IoT Hub, and then Relay actually allows us to connect our on-prem or our cloud systems with our on-premise systems as well. So this is a good example of using the cloud messaging systems to build out a resilient solution. So you can see here, this basically solution is for a taxi booking service. So people that are wanting to book a taxi, and then we're also tracking on the other side where those taxis are and how far they are away from the person doing the booking. So if we go through here, looking at a person booking the application, the user submits a booking request through the web application, and then we're actually using a service bus queue to actually process or to queue up that request from that user, so we can instantly respond to the user and say, yep, your request is in a queue, without blocking the user interface for the user. And then from there, a logic app actually listens to the service bus queue, and then it starts processing incoming bookings. And then we've got an Azure Function app, which actually connects back to the data to actually see where those, where if a taxi is in a location that can service that user. And once that's confirmed, then a message is pushed into a service bus with either confirmed or rejected. From there, we can notify the user, like in however we like, if it's through a SignalR connection to the client or through an email or both, then we can choose what we want to do with that. On the other side, we've got an event hub, which ingests a stream of the telematics for where the cabs are. From there, the event hub captures that information and puts it into a storage blob. The event hub then emits an event to the event grid, which goes out to the Azure Relay, which goes to the on-premise service, and then the on-premise service actually picks up the storage blob and then actually processes that, which is then used by the Azure function, so connecting both sides of that equation. So we can actually see here another great example of where queues have been used to decouple systems and make systems responsive for users straight away. So you can see here somebody's coming through our Azure front door. Then we're going through to the app service and we're using the queue. And that queue is actually decoupled, so that service is able to respond to the user straight away, and that queue actually is handled in the background for whatever logic that we have. So this one is a more complex setup. So this is basically an enterprise integration solution for multiple systems. So this is like SaaS systems, third party services, also like your own services running in Azure. So then we're using an API gateway, and this API gateway is then connecting to the workflow and orchestration. Otherwise, it's connecting to web services that you have running. And then from the workflow and orchestration, we're sending things out through the service bus, or we're connecting to the third-party systems or Azure services, and then sending things. We're basically using queues and events to decouple our system and to allow for that like scalability and resilience. So this is another example of adding resiliency to your application. So this is actually an API gateway that's connecting to a microservice. So you can see here the client mobile application is connecting to the API gateway, and then we're using this is actually built in to a tool called Poly. It's a .NET tool that actually allows you to do retries. There's a bunch of different things in it, like a circuit breaker as well, and there's also like a few other patterns as well. But the main one that we're looking at here is the ability to say, okay, well, the first attempt didn't call, let's try it again. And then after a while, it'll actually do a circuit breaker, so it doesn't actually do a denial of service to the microservice. So I'd recommend checking out Poly and if adding it to your applications if you want to add that extra resiliency. So now I'm just going to go through and do some tips for microservices. So if you're planning to thinking about doing microservices, there's a few anti-patterns that you really want to stay away from. So when you're building microservices, databases or whatever data store that you're using needs to be private per that microservice. So you should never have any microservices connecting to any sort of shared data source. And you also want to add in only eventual consistency between different microservices using sort of an event-driven architecture. So this is another design pattern that you can use for microservices. So you can see here, this is a backend for a front end. So you can see here over the left, you've got your client mobile application, which is connecting to an API gateway, which is specifically designed just for the mobile device. And then this gateway is actually then connecting through to the different microservices that we have. It's the same for and the web applications as well, connecting through the API gateway, which is specifically designed for the web application. So another anti-pattern is using basically blocking HTTP calls between different microservices. So you can see here, a client comes in, they're connecting to their basket, which then connects to the ordering, which then connects to the catalog. And then if any of these services are down, then it can actually affect the system as a whole. So a better option is to use the asynchronous communication. So you can do that through like RabbitMQ or a messaging system. So you can see here when the client comes in, the synchronized request actually comes in and then goes straight back to the user, so we're not actually connecting through. And then going through all the other systems, we're actually using non-blocking asynchronous calls. So you can do that through a messaging system, or you can do it through polling as well on the HTTP client. So this is an example of that event-driven communication. So if we have a look at the user profile microservice, updating the user command, which comes in and updates the local database. Once that's actually complete, then we actually send out an event through our event bus, and we go through to the different microservices and update the data that needed to be updated relevant to those microservices. So actually my microservices demo is broken at the moment. But what I can do is I'll just take you through some of the code that we have. So this is an example microservices codebase called eShop on containers, and this is provided by Microsoft, which is basically a Microsoft or a .NET application that's been broken up into different microservices, which you can easily download from GitHub. So if I actually look through here and go down to the source, you can see here we've got all the different services here. So under the services, we've got the basket, the catalog, the identity, the ordering. So if we have a look at the basket, it's got the API in there. And then for each of those APIs, they've got their own Docker files. If we go back up, so that was the source. You can also see that the sample application has the backend for a front end aggregators. So you can see here, if we go into the controllers, that's the .NET code for the backend for a front end. This is a really good sample application because it actually has different ways to deploy. If we go and have a look at the deploy folder here, under the deploy, we actually have the Kubernetes deployment. So you can actually see here the Linkerd setup. So the Linkerd setup will actually allow us to easily add the resilience in our system. So previously I talked about using Poly to add resilience to your system. What you can actually do, which with Linkerd, is actually go and install Linkerd. Let me have a look. So if you have a look at Linkerd, there's a bunch of different features that you get. So this is where I'm talking about with the AKS, where it runs Kubernetes natively. You can go and add all these service meshes, whatever open source service mesh that you want to add into your application very easily into your native Kubernetes AKS solution. And then you can actually use any of those the same way as any person would use on any cloud platform. So you can see here, in this case, it's using Linkerd. For deployment, we're using Helm. So what I might actually do is just see if I can get this up and running. So what this command is doing is basically just running a PowerShell script, which I can run on my Mac to deploy everything. And it's going to be using the service mesh. So we can actually go back up here and we can actually have a look where so that the container instances. So this is where I actually published that container previously. And also we can have a look at this Kubernetes service that I've created. And this is the Kubernetes service that's being used in this application. So I've already actually set the services up here. So we're just going to wait for that deploy to deploy. So while waiting for that, I'll just go back through and finish this off. So just to sort of go through a bit of a summary. Modernization helps us with agility, our CI/CD. It helps us get to market quicker. It helps us have that high availability very easily because we're leveraging the cloud platforms and all the hard work of other people, and it can help us reduce our costs. A modernized app is a containerized, possibly containerized or not necessarily containerized application, depending on like how you want to approach it. But it's also got resiliency. It's highly available. It's observable, so you've got those application insights of your application, and you also have CI and CD automated. If you can, look at what opportunity for retiring applications, replace if you can easily replace them. If you want to use the Power Platform to replace it, it's probably a good option to look at. Learn to love Docker because it runs everywhere. And in some cases, Azure App Service is enough for just if you're running a small pool of applications. It is more expensive than running things in containers and microservices, but obviously you have to trade that off with how much work you're actually going to be doing managing your Kubernetes cluster. And prefer AKS over Service Fabric unless you need Windows containers or stateful services. So that's run, let's just see. So now that I've actually got the deployment, we can actually see the status of the deployment. So they're not all available yet, so we'll just wait for those to be available. So there's two great books that go into modernization and also talk about microservices architectures. I'd recommend these books even if you're not interested in doing containerized .NET applications, because a lot of the design patterns go across technologies. It's got a lot of great references for from like industry leaders about building microservices architectures and the way to create them in a scalable and resilient way. So as any next steps, then I would recommend having a look at the Azure Architecture Guide, which really just goes through a bunch of it's very great knowledge on actually how to build a beautiful system on Azure, but also has in-depth things of messaging and when you should use them. Also on choosing your different compute type, goes into the basics of architecture, but also into the more advanced stuff. There's also a Microsoft lots of things about microservices and app modernization on Microsoft Learn, which is a great tool as well, or a great learning place as well. So it looks like I'm available. Let's just have a look and see if this is going to work. Oh, no, it's not working. I broke it earlier, so I have to go back and figure out what's wrong with that. So I'm just going to go through and see if there's any questions. Just 1 second.
So it does look like we have 2 questions here, Michael. Are you
Yep.
able to have a look in?
Yeah, having a look. Yeah, question is Service Fabric Mesh intended to be used now instead of Service Fabric? Yes, as far as I know, the mesh is like a service, a mesh that actually allows you to use for, or basically manages. It's a mesh that's on top of Service Fabric that takes care of a lot of the hard things for you. Alistair, I use DDD so I can switch my DDD app services to any architecture. Have you seen the DDD drone app Microsoft did? No, I haven't, but I'll have a look.
Cool, I think that's all the questions we have. Please do keep your questions coming if anybody has any. I'm just going to put, so I've just put in there a link to our survey and our YouTube channel. So if you've missed anything, any section from today, you can just check out the video. It'll be uploaded, the recording will be uploaded within the next 48 hours or so. So you can check it out there by the YouTube channel. Michael, did you have anything else? Oh, we've got one more question's come through. 1 second. Okay. Okay, Alistair again. I'm just going to publish this one. So can you see that one at the bottom?
Yeah, so are you sure containers are cheaper than app services? So in the case that the containers end up being cheaper if you're running lots of servers. So you get a higher density per virtual machine, or with container instances, you get a higher density. Where app services is you're using a whole app service for your application.
Okay, great. Is there anything else you'd like to add? We don't have any more questions that have come through. Seems like you've covered everything for today.
Yeah, that's it. Thank you everyone for coming, and if you have any questions, then please get in contact.
Awesome, thanks, Mike. Did you have a slide at that end there that you were just showing your contact details you wanted to put up quickly?
Yeah, let me just put that up.
Just for everyone to have a look.
Let me see if I can go to it.
All good. Cool. Awesome. Well, thank you everyone for tuning in today. I just put our website link there as well if you want to check out any upcoming events. And thank you, Michael, and thank you everyone for tuning in on your lunch break today or wherever you are in the world. Have a good rest of your day, morning, evening, and we'll see you next time. Thank you for tuning in.